Hello everyone, today we are back with another Leetcode question. So this is the question of the day, and I'll straight up come um, to the problem statement. So the problem statement is very straightforward, and the question number is 2115 if you want to just attempt it before seeing the solution. So the problem statement says that we are given a list of some recipes. Okay, so for example, in our case, I'm explaining using the third example because I can explain the failure case as well. So in the recipes, we see three recipes that are required to be made, and we are given ingredients. So the length of the ingredients will be same as the length of recipes. So ingredient will be a list which will contain all the ingredients required for the ith recipe. For example, if we want to make sandwich, then what are the things required? We'll go to the second list, that is bread and meat. So similarly, for burger, similarly for bread, we have some ingredients. Now, initially we are given some supplies. So supplies has yeast, flour, and meat, and there is no limit to how much they are available. They are available in infinite quantity, and we have to tell what are the recipes that are possible. So we kind of feel that there is a dependence, right? So for example, if we have, like, let's say 1 2 3 recipes, we have a set of ingredients that it is dependent on. Second is also dependent on set of ingredients, third is also dependent on set of ingredients, but there is a catch. Even the first recipe can have, let's say, third recipe as a ingredient as well, and second can have first recipe as an ingredient as well. So we see there is a cyclic dependency over here. This actually gave me an idea of using cycle detection. uh, so that is a way, and there are other approaches as well, like, but I'll be discussing the approach that I followed for this. So what I initially did, I took the list of recipe, I created a dictionary of the recipe name as the key, like let's say one, and the ingredient as the list of ingredients as the value for that. So for example, I created a list named di. What I did was I attached bread as the key, and the value was the ingredients required for making bread. So this di is used for that. D2 is another dictionary. This is used for basically mapping, like let's say if amongst those recipes we have visited a recipe, then it will be marked 2. Initially, all of the recipes will be marked 0 because we have not visited any recipe. If we are visiting a recipe, so detect cycle detection, the way to detect a cycle is this only, right? We see a node, we go to its adjacency nodes, and then we go to all the adjacency nodes, and while visiting this, if we find the initial node again, then that there is a cycle. So that's what I have done. So initially all the recipes are 0. Once we have started visiting a recipe, I'll make it 1, and once we have visited a recipe, we'll make it 2. So that's what I have done here. I'll discuss solve function later, but initially I've iterated over the recipes, and if in the second dictionary the value is 0, that means if it is not visited, then I have called solve with that recipe name. Now what happens in the solve function? In the solve function, I have simply seen that if the current recipe that has been passed to the solve, is it already being visited? Like, we seeing it from within another recipe? We saw one recipe, then we saw another recipe, then once we start visiting first recipe, we marked it 1. So we saw that in its ingredient we need a recipe, or we need a supply, we use that. But if there is a recipe within this recipe A, if there is a recipe B, and within that recipe B, let's say we have a recipe C, but within this recipe C we have an ingredient that is A again. So there is a cycle. Okay, so it's kind of a deadlock. We cannot make A because within this cycle we also require A. So that is what I'm trying to do. For that purpose, I'm checking if the recipe is already being visited, then we return false. If not, then we simply mark that recipe to being visited now, and we set use a variable called pos, that is basically possible, and we set it to true. Now we iterate over the list of ingredients that it requires. So what we do, you see, di we iterate over the ingredients, and we know that initially di was used to save the ingredients for a recipe. So this I created a dictionary so that we can quickly reach to the ingredients that are required. And within that, if the I is present in supplies, then straight up it is present, it is given in infinite quantity, so we can continue. Or if I is present in di, or it means if I, the ingredient is all present in the recipe, if it is already another recipe, then we call pos equals to solve I, we call solve again with the new ingredient, and the ingredient is a recipe in itself. Okay, and that will again try to solve it within itself. Else, if it is not present in both, then we set pos to false. There can be case like, let's say I randomly have an ingredient named UDAY. Okay, I have Uday named ingredient. It is neither present in a recipe nor present in supply. So definitely we have to return, we have to set it false, right? It is not possible to make it. So we set pos to be false. And if pos is false without reaching the end, before reaching the end of the list of ingredients, if pos is already false, we break. Now we mark that this particular recipe, I have finished visiting this recipe. Okay. And once that is done, I see if pos is true. That means it was possible to make it. Then I append the recipe to the answer, and I also append the recipe to the supplies. So why I append it to supplies is so that I don't, for further calls, I don't go ahead and keep calling the solve function for a recipe. See, in the supplies, if it is already present in supplies, I can quickly find it. And one more thing, I have made supplies from a list, I've converted to set for order of one access. So if it is present in supplies, if it is possible that it can be made, I simply add it to supplies so that it can easily be found. Once that is done, I return true from here. If it is not possible, I will return false. So this is the simple way. And you can see, like, if, like, let's say, if the bread is having as an ingredient, it also had sandwich over here. Okay, and if let's say sandwich was already possible, sandwich will become the part of the supplies as well. Okay, so while solving bread, I will already, if sandwich is its ingredient, I will also solve sandwich. So this will also avoid looking into sandwich again. So like, let's say if we go to D2, while we were solving K, that was bread, I went into solve sandwich as well, because sandwich was already an ingredient for bread. Okay, so next time when K moves to sandwich, I will see D2K equals to 0. No, since it will already be marked as equal to 2, so I don't need to see that, and simply will move to the next ingredient, that is burger, and so on and so forth. So this was a simple question, not that simple. I luckily was revising graph related topics yesterday, so I think that's the reason I basically got this particular approach. Or else this is topological sort is the standard way we have to do this. And thanks for following up till here. Keep coding and hope you enjoyed the video. First of all, do try to solve this on your own, and then if not possible, do look into the solutions. Thanks a lot.